So continuing on, the y value needs to be -1 and the r is √2. So these will be √2 there, and the y's are -1. So then each of these angles is going to have a sine value of -1 over √2. This is a 45, 45, 90 triangle. Then this angle generating it would be 180 degrees plus 45 in here. That'd make 225 degrees. This angle here, since it's a 45 degree, would be past 180, past 270, and it would go another 45 degrees past 270. So 45 plus 270 is going to be 315. So which of these two angles is a valid output for this function? Let's go to the range of the inverse trig function. The range of angles for sine need to be between 90 degrees and -90 degrees. Now, I look at this and it doesn't look like either of them are between -90 and +90 degrees. But actually, it turns out that this angle does fall in that acceptable range. Because if we think of this angle and we take it in the negative direction, then if we go -45 degrees, that will put us in the same spot, and we would get the same sine value. So this angle, -45 degrees, would put us in an acceptable output. This would be -45 degrees, and if you needed to give that in radian measure, then that would be -pi/4. And if you needed to give this one in radian measure back here, it would be pi/6. Last two. So cosine. We have cosine, which is x over r, and we want to know which angle or angles has a cosine of -√3 over 2. So this negative has to apply to the x because it can't apply to a radius. X is this direction, so we're going to have a triangle which has a -√3 for the x and a 2 for the radius, meaning that we could also have a triangle down here, also with a -x and a 2 for the radius. For each of these triangles, these would be a 30, 60, 90 triangle because I see there's a √3 in there. Then we would have a 1, √3, 2 triangle and a 1, √3, 2 triangle. So this would be a 30-degree angle here. This would be a 30-degree in there. So the angle then generating this first triangle would be 150 degrees. And the angle generating that second triangle would be past 90, past 180. It would go 30 degrees past 180, and that would be a 210-degree angle. So now, which of these angles falls within the acceptable output for the cosine inverse graph? So the acceptable outputs run between 0 degrees for our angle and pi for our angle. Now remember that pi is 180 degrees. So it needs to fall between 0 and 180. That would be this angle here, 150 degrees. Not that one. In radians, 150 degrees is 5 pi over 6. Last example. You've got tangent inverse. Tangent inverse of 1. I like to think of this number 1 as the fraction 1 over 1. Now remember that tangent is y over x. So I'm going to make a triangle with a y and an x, each of 1. Turns out I can. The 1, 1, root 2 triangles have that property. Can I do any other triangles where the y over x would be 1? Over in quadrant 3, if y is negative 1 and x is negative 1, that would also be y over x equal to 1. In this case, it would just be negative 1 over negative 1. So these two angles do the job. So I've got a 45 in here and a 45 in there. So this angle, of course, is going to be 45 degrees on the nose. This one goes past 90, past 180. 45 more, giving 225. Yikes. So raise you. 225 degrees. When we go to our inverse cosine, we see that angles need to fall between negative pi over 2, which is negative 90 degrees, and pi over 2, which is 90 degrees. This angle does not qualify, but this 45 degree angle does. So that equals an output of 45 degrees, or in radians, pi over 4. And that's what we have for today's lesson. See you in class.